We're going to have a go at the following integral on the board today. So this is the integral of x cos x with respect to x. So how would we do this? Well, when you've got yourself two functions sat next to each other that are very different, in other words, they don't simplify with each other nicely, you may want to go down the road of using integration by parts. Integration by parts says if you can view two pieces written as a product as a u piece, so this is a piece that we can differentiate, and another piece as the dv piece, that is a piece that we can integrate. If that's how you view two pieces that are a product to be integrated, we can use uv minus the integral of v du as a way to work this one out. What else we can do is we can recognize that sometimes certain pieces being the differentiation piece make a lot more sense than others. Here, x is a very, very good choice. The reason why x is a good choice is because it sort of differentiates away. In this formula here, when I write u in v, that's it, those bits are done. But you still have to do some integration of these bits here. Du, well, du for something like x would be just a number. So that will mean that this whole thing here will be much, much simpler. Because of that, we often use sort of tricks that generally give us a good idea of which piece to assign the differentiation piece. The differentiation piece, using logs, then algebra. The others really sort of, that's pretty much as far as you normally go. But trig and then exponential in order of priority tends to, notice tend to, being the key idea. These tend to be good ideas, but it's not foolproof. So let's have a go at it now. So we're going to view this part here as our u piece, if you like. So u equals x. And we're going to view this other piece here as the dv piece. So I tend to like laying my working out like this. The formula means that integrating something in this format leads to uv minus the integral of v du. So we're going to need to work out a few more bits and pieces, and then we're just going to put these results in. So du is 1, as we said before. V is required for this, requires an integration, which is sine x in this case. Now what do? We put the different pieces in here and we see what we get. uv, v du. Okay, so let's just write the pieces in and let's see what happens. So uv means this is going to be x times v is sine x. So that's the first part here, all done. Minus the integral. The integral is going to be v du. Notice because of that 1 has really helped out. It means that it's just turned into integrate sine x. This bit here, it's done. You don't need to do anything else. So the whole thing just turns into x sine x minus, well, I do actually need to integrate sine now. So it's actually like I sort of need to go again one more time. So I'm going to say that is, and I'm using a bracket here to be careful, I'm going to say minus cos x. I'm going to put my plus c down now as well at the same time. So by parts, it all turns into the following. X sine x plus cos x plus c. So what did we see there? We said that when we have a product of two very different functions, integration by parts is often the way forward. And this is sort of the way that I like to use the formula, which you can find in the formula booklet. You'll often see many people talk about how to prioritize the differentiation bit. In this case, we sort of picked algebra, but we talked more generally about why that was a good choice. Okay, so this part here on the left is not foolproof, but it works pretty well with that Excel A-level. We then wrote out the pieces that we knew to start with. We worked out the other pieces, and we put it all together in the format that we needed. uv minus the integral, I always remember, video. Okay, so I hope you can have a go now at a similar question for yourself. try this one and tell me what you get in the comments below.